Hello everyone, welcome to my YouTube channel TechSpot. This is me, Harish Goupale. So basically in today's video, we are going to discuss about demultiplexer and the different types of demultiplexer and the RTL design implementation of 1:2 demultiplexer by using Verilog and SystemVerilog construct. Same for 1:4 demultiplexer. Now if I talk about demultiplexer, so basically it's a combinational circuit that takes a single input and it routes to the one of the many outputs based on the select line. Basically it is often called as data distributor who distribute data on the multiple destinations. Now based on the select lines, there are different types of demultiplexer such as 1:2 demultiplexer, 1:4 demultiplexer, 1:8 demultiplexer and 1:16 demultiplexer. Now if I talk about 1:2 demultiplexer, so it takes single input, it can be I, it has one bit select line and two outputs, it can be Y0 and Y1. So based on the select line, input I will be routed to either Y0 or Y1 based on the select line 0 or 1. Now if I talk about truth table of 1:2 demultiplexer, so we are having input I, select line that is 0 1 and output Y0 and Y1. If select line is 0, then input I is routed to the output Y0. That time Y1 will hold the 0 data. When select line is 1, then input I is routed to the output Y1. That time Y0 will hold the 0 data. Okay. Now if I talk about 1:4 demultiplexer, then it has also single input that is I and 2 bit of select line and 4 outputs. It can be Y0, Y1, Y2 and Y3. Now based on the select line, input I will be routed to the output Y0, Y1, Y2 and Y3. Now if I talk about truth table, so we have input I, select line 0, 1, 2, 3 and outputs Y0, Y1, Y2, Y3. If select line is 0, then input I is routed to the output Y0, other output is holding 0 data. If select line is 1, then input I is routed to the output Y1, other output is holding 0 data. Now if select line is 2, then input I is routed to the output Y2, and if select line is 3, then input I is routed to the output Y3, and that time other output is holding the 0 data. Now let's jump for the RTL design implementation of 1:2 demultiplexer and 1:4 demultiplexer by using. You can see my screen. I have already written a Verilog code for the RTL design implementation of 1:2 demux. So let's go through each line of code. Here my tick time scale is 1 ns divided by 1 ps. My module name is demux 122. I have 4 bit of input I, 1 bit of select line and 4 bit of output, that is Y0 and Y1. Now inside the procedural block, I have used here case statements. Basically based on select line, I have assigned input I to the outputs. So if select line is 0, then I have assigned input I to the output Y0. And when select line is 1, then I have assigned input I to the output Y1. When I execute this code, then it gives me the schematic. If you see the schematic, based on select line, input I is assigned to the output Y0 and Y1. But if you see, it has generated an unintentional latches, because here if you see, so this generates an unintentional latches because incomplete assignments to the output Y0 and Y1 within this combinational procedural block. We know that a combinational procedural block executes whenever of its input changes, then only it infers the combinational logic. Okay, so basically to avoid the latches, all output that is Y0 and Y1 must be assigned for every possible case statement. And if you see here the issue, for every possible case statement, only one of the output is assigned by the input values. Okay, and that is the reason this logic has inferred an unintentional latches. So then what is the correct logic? The correct logic is we have to assign output. We have to assign output for every possible cases. We have to assign input for all the output for every possible cases. So if you see below the correct logic, I will comment this logic. I'll uncomment this logic. So here you can see inside the combination procedural block based on select line. So for this case, for the case of 0, what I did, I have assigned inputs to all the outputs. If select line is 0, then I have assigned I to the output y0 and 0 output to the output y1. Okay, as I have explained in the truth table also. And when select line is 1, then I have assigned input I to the output y1 and 0 to the output y0. Now if I save this and if I reload the schematic, then you can see this logic will not enforce unintentional latches. So you can see the schematic based on select line, input I is assigned to the output y0 and y1. So this logic is correct. Now to verify this 1:2 demux, I have written small test bench for this. So you can see my TB name is TB for 1:2 demux. Okay. And here also I have 4 bit of input I, 1 bit of select line, and 4 bit of output, that is y0 and y1. Here I have taken an instantiation of demux 1 to 2. Okay, and inside the initial begin we have 2 possibilities. Select line is 0 and select line 1, and for this I have assigned some values to the input I. Now we have click on this run simulation and we'll check the waveform whether it is working as per the functionality or not. So here you can see that. Here you can see when my select line is 0, that means input I is assigned to the output y0. Here you can see 5. When select line is 1, then input I is assigned to the output y1. Here you can see 8. When again select line is 0, then 2 is assigned to the output y0. So this is how 1:2 demultiplexer works. Now let's jump for the RTL design implementation of 1:4 demultiplexer. Here you can see I have already written a Verilog code for the RTL design implementation of 1:4 demultiplexer. So let's go through the code. Module name is Demultiplexer 1:4. Here we have taken 4 bit of input A and 2 bit of select line and 4 bit of output, that is y1, y2, y3 and y4. Now here also I have written incorrect logic, same like while implementing 1:2 demultiplexer. Inside the combination procedural block based on select line, here you can see I did not assign inputs to the all possible output for a particular case. So if you execute this code, then obviously it will enforce the unintentional latches. So but below you can see inside this combination procedural block always begin based on particular select line, I have assigned inputs to all the possible outputs. So if select line is 0, then I have assigned input A to the output y1 and input 0 to the output y2, y3 and y4 as per the truth table of 1:4 demultiplexer. Okay, if select line is 1, then input A is assigned to the output y2 and I have assigned 0 to the output y1, y3 and y4. Similar for all the cases. Now if I execute this code, then it gives me the schematic. So here you can see based on the select line, input A is assigned to the outputs y1, y2, y3 and y4. Now to verify this demultiplexer 1:4 demultiplexer, I have written simple TB code. Let's go through the code. Module name is TB of demux. Same input and output signals, that is 4 bit of input A, 4 bit of outputs, that is y1, y2, y3 and y4 and 2 bit of select line. So if 2 bit of select line, then 4 combinations will become. Now inside the initial begin, based on the I have given select line values and input values to the A. You can see direct values. A is equal to 5, select line is equal to 0. After 20 nanosecond, value of A is 7 and select line is 1. Okay, and after 20 nanoseconds, select line, when select line is 2, then I have assigned 9 to the input A. Now if I click on this run simulation, as I have already run this, So here I will click on this waveform. You can see the waveform. When my select line is 0, then the input A, that is 5, is assigned to the output y1. When select line is 1, then input A, that is 7, is assigned to the output y2. When select line is 2, then input A, that is 9, is assigned to the output y3. And when select line is 3, then input A, that is B, is assigned to the output y4. Okay, so this is how 1:4 demultiplexer works. So basically in this video we have discussed demultiplexer and the RTL design implementation of 1:2 demultiplexer and RTL design implementation of 1:4 demultiplexer. Also we have discussed the incorrect logic which infers the unintentional latches and the correct logic. Okay, so here I will stop the video. If you are watching this video, then please click on the like button, and if you are new to this YouTube channel, then please subscribe to my YouTube channel. Thank you so much.